All right, so we're going to look at the first part of being able to solve a linear system by elimination. So we've talked about solving by graphing, we talked about solving by substitution. Now we're going to solve by what's called elimination. Now when you hear the word elimination, you think we're removing something or we're getting rid of something, okay? Now the whole idea behind elimination is we want to determine what are called additive inverses, or we can think of it as opposite coefficients, okay? For instance, if I had 4x and I add to that a negative 4x, okay? Or you could think of 4x minus 4x. Either way, one is a positive, one is a negative, so they're opposite coefficients. Well, what's going to happen if I add 4 and a negative 4x, or essentially 4 minus 4x? Well, they cancel each other out and we get 0, right? Now, in our context, we're not going to really worry about 0, but they cancel each other out, okay? That's the whole idea behind elimination here. Now, there's really 4 steps that we're going to be taking here. We're not going to do so much multiplying today. Today, we're just going to focus on being able to add and subtract by finding our opposite coefficients, like a positive 4 and a negative 4, okay? But the first step is always check to see if we need to multiply one or both of the equations, okay, it could be one or both, by some constant so that at least we have one pair of opposite coefficients, okay? So that's what we're going to be looking for, is opposite coefficients that we can add or subtract, like we talked about here, that would essentially cancel itself out, okay? Now, after we add or subtract our opposite coefficients, that's going to eliminate one of the variables, okay? So we're either getting rid of x or we're going to be getting rid of y so that we only have one variable left, okay? That's where it kind of comes similar to the substitution examples that we looked at before, okay? We're going to solve for that one variable, and then just like substitution, once we solve for that one, we plug that back into the original equations, into one of the original, and then solve for the other variable to get either the x or y that we haven't solved for, okay? So that's the steps we're going through. Now, I provided an example problem of what that would look like. Specifically, today we're only going to focus on adding or subtracting when both of the equations have at least one pair of opposite coefficients, okay? So we're only today just looking at those that already have opposite coefficients given to us. For instance, when we look at this example here, okay, it says solve the system of linear equations by elimination. Notice, 3 is the coefficient of x, and 3 is the coefficient of x of the second equation. But are those opposite coefficients? No, because they're both positive. We need a positive and a negative, okay? However, if we look at the 2y, the coefficient of the first equation of y is a positive 2, and in the second equation, it's a negative 2. So those are opposite coefficients. That's what we want. That's what we're looking for, okay? So one example of applying elimination here is once we find our opposite coefficients, we could add these equations. Sometimes we'll look at later subtracting, but we could add these equations together, in which case, if I added 3 and 3, I would get a 6. And opposite coefficients, this is why we're looking for it, they cancel out, okay? They go away, they eliminate, okay? So once we get rid of that, instead of having x and y, now we're just down to one variable, in this case, x. Then, of course, if we add 4 and negative 4, 4 minus 4 would give us 0, okay? Then it just turns into solving for x. Well, I would divide by 6 to both sides, okay? That's what they're doing here. And then 0 divided by anything, we would get x equals 0. So now I have at least the first part of the solution, the x-coordinate of the point that I'm looking for. Then, just like what we did in substitution, we would take this value and substitute it back into either one, doesn't really matter, either one of the original equations, and then solve for y. Okay, they plug it back into the first equation. So they say if I plug in x into my first equation for x, or excuse me, plug in 0 for x, then we'd have 3 times 0 plus 2y equals 4. Well, 3 times 0 is just 0. We don't need to write it. You could put 0 plus y, but there's no point here. Okay, so we'd have, if there's an in-between step here, it'd really be 2y equals 4. Okay, for an in-between step. And then if I divide by 2 to both sides, I get y equals 2. okay? So the solution would be, if y equals 2, the point solution would be the x value was 0, the x value was 0 and the y value was 2, okay? So that's the point where both of our linear equations intersect where they cross. That is the solution, okay? So that's the idea behind elimination when we're adding or subtracting, okay? Is that I can take the top equation and the bottom equation, look for, get rid of all this mess here, look for opposite coefficients, and when I add them together, they cancel out, and then I'm just solving for one of the variables, okay? Let's try a couple of examples, okay? Let's try one with adding, and then I'll show you what happens when we need to subtract, okay? So let's look at number 1 here. Now, if we look at the x values, this x and this x, do they have opposite coefficients? No, okay? So let's look at the y's. Do the y's have opposite coefficients? Yes. 5, a positive 5, and then we have a negative 5. So if we add these two equations together, our positive 5 and negative 5 will cancel out, okay? So that's what we want to look at here. So if I add these together, we'd have a negative 3x and a positive 5x, different sign. What do? Subtract and keep the sign larger, so 5 minus 3 is 2. So we'd have 2x, and 5 is bigger and positive, so it'd stay as a positive. Then our opposite coefficients will cancel out, okay? Now, essentially it's 0, but again, we don't need to write 0. They just cancel out. They eliminate. Then we have 17 minus 5, which would give us 12, okay? Now it's just solving for one variable. In this case, I have 2 times x equals 12. The opposite of multiplication is to divide by 2, and we get x equals 6, okay? So now I have part of the solution. I have the x-coordinate. What I need to do is to go back to the original equations, doesn't matter, and plug it back into one of these, okay? Let's plug it into the second one. Why not? So let's plug it into 5x minus 5y equals negative 5, okay? So if I plug in 6 for x, we'd have 5 times 6 minus 5y equals a negative 5. Well, solving for y, 5 times 6 is 30, okay? And then I need to get y by itself. This is a two-step equation, so treat it like when we're solving for x. I need to subtract 30 over, the opposite of a positive 30, subtract 30 over. And we'd have negative 5y, don't lose that sign, equals. Now this is same sign, okay? So we have two negatives, so it's same sign, add and keep the sign. So we're going to get 5 and 30 is going to give us 35. And then we keep the sign, which is negative, okay? Now we have to undo our multiplication, so we're going to divide by a negative 5 to both sides. And we get y equals, well, a negative divided by a negative is a positive, and 35 divided by 5 is 7, okay? So my solution, my xy here, the point where these lines intersect, is 6, 7, okay? Now that's with adding in additive inverses, okay? But I also want to show you what happens if we don't have opposite coefficients, in which case maybe they're both the same value, but they have the same sign. Remember, we need different signs, a positive and a negative. If that's the case, let's look at an example like number 3. Are the x values, our coefficients here, are they opposite coefficients? No. What about the y values? Are they opposite coefficients? No. Well, now we have a problem because earlier all we had to do was add it together and we were good. Well, if you ever run into this situation, here's what you need to look out for, okay? Notice that the coefficients of x over here, are they both 6s? Yes. So they're almost opposite coefficients or additive inverses. The only difference being is that they're both positive. Now, if they're both positive, what we could do is we could subtract them, or in a way you could think of it as I'm really multiplying a negative to each one. That's essentially what we're doing. But I'm going to subtract these guys instead of adding them, okay? If that's the case, then we'd have 6x minus 6x, and that would cancel them out. That would eliminate them, okay? So if you have two positives or two negatives of the same coefficient, you can subtract them, okay? So instead of adding these, let's subtract these. 6x minus 6x, Now that goes away and we don't have to worry about it, okay? If I take a negative 8y minus a negative 7y, think of it this way, a negative 8y minus a negative 7y, remember that when we subtract a negative, that really means addition, okay? So we have a negative 8 plus a 7y. Well, 8 minus 7 is 1. Then we keep the negative, so we have a negative 1y, or we could just say negative y, equals, okay, I'm going to write it to the side here so you can see it, a negative 24 minus a negative 8. Well, again, if we minus a negative here, it's really addition, so we'd have a negative 24 plus 8, so we're going to have 24 minus 18, keep the sign of the larger value, which would give us 6, and then 24 is bigger, so it'd be negative, okay? Now, the last thing here, even though we have a negative y equals a negative 6, technically the y is not by itself. We need to divide out this negative. We can treat it like dividing a negative 1 from both sides. Negative and a negative make a positive. Negative and negative make a positive, and 6 divided by 1 is 6. So now I've solved this for y. Now we got to plug this back into one of the original equations and solve for x. Let's plug it back into the first one since last time we did the second one. Okay, so we'd have 6x minus 8y equals negative 24. And we're going to plug in a 6 for y. So we have 6x minus 8 times 6 equals negative 24. Well, solving for x, we'd have 6x, a negative 8 times 6, or you can think it 8 times 6 and then just subtract. Either way, we're going to get a negative 48 equals negative 24. Two-step equation here, we need to add 48 to both sides. This goes away and we get 6x equals, different sign, what do? Subtract and keep the sign of the larger, so 48 minus 24 is 24. 48 is bigger and positive. And then last thing, dividing by the coefficient of x here, we get x equals 4, okay? So my point, or the point in which they cross, is 4, 6, okay? That would be the solution here, okay? So just keep in mind, if you have additive inverses, just add them. If you don't have additive inverses, but it's really close, they have the same numerical value, just different sign, subtract them, okay?